Hello everyone. In this lesson, we're going to focus on simplifying surds. Our key inquiry questions are how to identify and simplify a surd. Later, we'll focus on how to multiply and add or subtract surds. Firstly, what is a surd? Surds are irrational numbers written in square root format. Let's look at the starter question, which focus on surds and how to identify surd. Here is a starter question. What's the same and what's different? As we can see, we have square root 2 and square root of 4 is 1.41, and the decimal places grows continuously without any recurrence. 9. Now we have square root of 81, which is equal to 9, because 9 multiplied by itself gives you 81, and square root of 9 gives you 3. Now square root 2 is a surd because we can't be square rooted, whereas square root 81 and square root 9 are not surd. To summarize, a surd is a square root which cannot be reduced to a whole number. Here are some of the examples of surds. Square root 2 is a surd, square root 5 is a surd, even though square root 81 looks like a surd, but it isn't really, because square root 81 is equal to 9 and we got rid of the square root. Let's look at multiplication of surds. The general rule, square root of a multiplied by square root of b is square root of ab, where a and b are multiplied as both of them are under the square root. For example, square root 4 multiplied by square root 9 is square root 36, which is equal to 6. Square root 2 multiplied by square root 8 is equal to 2 times 8, which is 16 square root 16, and 4 multiplied by 4 is 16, hence square root of 16 is 4. Using the example provided earlier, can you please attempt the following questions on a piece of paper or in your exercise book. Once completed, press play to check your answer. Now, please press pause to attempt the following questions. Here are the answers. Square root 3 times square root 12 is square root 36, which can be square rooted into 6. Square root 3 times square root 4 is square root 12. And just to focus on the final question, 2 multiplied by 3 is 6. 6 times 12 gives us 72, which is square root of 72. Now let's look at division of surds. Square root of 36 divided by square root 9. 36 divided by 9 is 4. And a square rooted square root of 4 is 2. Similarly, square root of 54 divided by square root 6 is square root 9, because 54 divided by 6 is 9. Square root of 9 is equal to 3. Now, I would like you to attempt the following questions on a piece of paper or in your exercise book. Press pause and attempt the questions. Here are the answers. I would like to focus on the last question. because it involves multiplication as well as division. Square root of 2 times square root of 9 gives us a square root of 18 divided by square root of 3. 18 divided by 3 gives you 6, which means the final answer is square root of 6. Now let's focus on addition and subtraction of surds. In the first question, we have square root of 9 plus square root of 16. We know square root of 9 is 3 and square root of 16 is 4. 3 plus 4, which gives us 7. We have a very similar question. However, the difference is we have the brackets, which is telling us to add first and then square root. 9 plus 16 is 25. Square root of 25 is 5. Now let's look at examples involving simplification or simplifying surds. We have square root of 12. How could we simplify square root 12? Square root 12 can be written as square root 4 times square root 3. We have chosen 4 by 3 rather than square root 6 times 2, because we know 6 multiplied by 2 gives us square root 12. Similarly, square root 4 times square root 3 also gives us square root 12. However, 4 and 3 are chosen because 4 is a square number and can be further square rooted as 2 multiplied by square root 3, which is 2 square root 3, because 2 is a non-surd or rational number and square root 3 is a surd because it can't be further square rooted. If I had broken 12 into 6 times 2 or square root 12 as square root 6 times 2, I couldn't have further simplified because neither 6 nor 2 are square number. Hence, this cannot be chosen. So during simplification, ensure you use square numbers as a factor because you can simplify them as they will be square rooted. Using this as an example, please attempt to simplify square root 72 and square root 12 times square root 27 on a piece of paper or exercise book. Once completed, you can verify the answers. Now, please press pause to attempt the question. Let's go through the answers. Square root 72 is broken as square root 36 times square root 2. And square root 36 can be square rooted into 6 times square root 2, which is 6 square root 2. Now 12 is broken down as 4 times 3, and 27 is broken into 9 times 3. The reason for selecting them, as I mentioned, 4 and 9 are square numbers and they are factors of 12 and 27 respectively. This enables us to square root the square numbers and convert the surd into rational numbers. Now, 2 multiplied by 3, as they're both rational because they don't have a square root sign, gives us 6 square root 3 multiplied by square root 3 gives us square root 9. As you may realize, square root 9 can be converted into a rational number, which is 6 multiplied by 3, which gives us 18. Finally, let's look at the example involving expanding brackets, which involves multiplication and addition or subtraction. You need to expand 5, take away square root 3 the whole squared in the form of a plus b square root 3. We could use grid method to multiply them easily. 5 take away square root 3, and that's squared, which means 5 take away square root 3 is multiplied by 5 take away square root 3. Now you could multiply the grid. 5 multiplied by 5, which gives us 25. 5 multiplied by minus square root 3, which would be minus 5 square root 3. Minus square root 3 multiplied by 5, which gives again minus 5 square root 3. Finally, minus square root 3 multiplied by minus square root 3 will provide us positive square root 9, and square root 9 is 3. Remember, multiplying two negative numbers will result in a positive number. Once multiplied, we can simplify them by collecting the like terms and adding or subtracting them. 25, take away 5 square root 3, take away 5 square root 3 plus 3. We know 25 is grouped, which is a rational number grouped with another rational number plus 3 gives us 28. Minus 5 square root 3 minus 5 square root 3 is minus 10 square root 3, just as we use, which is very similar to simplification of algebraic expression minus 5x, which gives us minus 10x, which is 10 square root 3. And this expression is similar to a plus b square root 3, where the value of a is 28 and the value of b is minus 10. And I've calculated it by comparing the two expressions. Now, I would like you to try 3 plus square root 5 the whole squared. Please use the previous question as an example and complete this question. Do your working out on a piece of paper or in your exercise book. Now press pause to complete this question. Once completed, press play to reveal the answer. Here is the answer. Now I would like you to click on the attached worksheet and start completing each question by typing in the answers next to the question or providing the answers below. Remember, you need to provide all the working out to get the full marks. Here are the questions and the extension questions are provided. If you find the worksheet harder, please refer to the attached YouTube video and scroll down to page 4, where you get the same question but it's scaffolded.